Okay, we continue back. In previous video, it was to mention that your R, gas constant is actually depends on the substance. So like for example here, your R is equal to 0.2968. It is for nitrogen. You can find this value from appendix A1 in your textbook. So let's see. So appendix A1, page 882. So in table A1, nitrogen is, the gas constant for nitrogen is 0.2968 kilojoule per kgK. So similarly for first question 4.14, your R is for the gas constant for air. Here 0.287. Also from table appendix A1. So air is 0.287 kilojoule per kgK. Okay. We continue with the next question. Question 4.20. Okay, sorry. So a piston cylinder device contains 0.15 kg of air initially at 2 MPa and 350 degrees Celsius. The air is first expanded isothermally to 500 kPa. Okay, isothermal, then compressed polytropically with a polytropic exponent of 1.2 to the initial pressure. Your initial pressure is 2 MPa. And finally compressed at constant pressure to the initial state. Determine the boundary work for each process. So all these three processes and the net work of the cycle. Okay. So I really love this question because in one question you have to solve for three cases. So let's work on for the first one. Okay, W1. It is isothermal. So MRT ln P1 over P2. Initial pressure over final pressure. Okay, so your M is 0.15. Your R for air is 0.287. Temperature must be in Kelvin. So 350 plus 273, you will get 623 Kelvin. Ln, convert the 2 MPa to 2 kilopascal, so you'll get 2000 kPa over 500. So solve for this and you will get W1 equals to 37.1 kilojoule. Okay, so this is for the first part. Second part, polytropic. Okay, the formula for polytropic is P3V3 minus P2V2 over 1 minus N. So 1 minus N. Okay, we know P3, we know P2, we know N. Right? We have to calculate for V2 and V3. So for V2, we have to use, PV equals to MRT. So V2 is equals to MRT over P2. So your M is 0.15, R 0.287, 623 for temperature, over pressure is 500 kPa. So you will get V2 equals to 0.054 meter cube. Okay, next for V3, you have since it's polytropic, so you have to use the relationship P3 V3n equals to P2 V2n. Okay. So your P3 is 2000. V3 we have to calculate the power of 1.2 equals to P2 500 0.054 1.2. So you have to calculate for this and divide by 2000, then you have to square root to 1.2. So V3 you will get 0.017 meter cube. So now we already have V3 and V2. So we can calculate for W2. So W2 is P3 is 2000 kPa, V3 0.017, okay, minus 500 0.054. Okay, scroll down. Over 1 minus 1.2. Your W2 is, I round out, you get negative 35 kilojoule. Okay. So last part, W3. W3 is constant pressure. So the formula is P V4 minus V3. Okay, we know V3 but we don't know V4, so we have to calculate for V4 using this relationship. So similar to how you calculate for V2. V4 equals to MRT P4. So M 0.15, R is 0.287, T 623. Okay, P4 is 2000. Okay, so you will get V4 as 0.013 meter cube. Okay, so now you already know your P4. V4, so your P is 2000. Okay, sit back to initial state. Okay, so W3 equal to 2000 V4 0.13 minus V3 0.017. Okay, so your W3 is negative 8 kilojoule. Okay, sorry. So let's summarize. So W1 is 37.18 kilojoule. W2 is negative 35 kilojoule. And W3 is negative 8 kilojoule. Okay, so this is for the boundary work. So your net work is the total of W1 plus W2 plus W3. So for all this, substitute here, you will get negative 5.8 solution. Okay, some of you may got a different answer, like negative 4 something, because here I round up the value for V4. That's why I got negative 8. Okay, some got negative 7 kilojoule. So, okay, anyhow, it's correct. So, this is your final answer. Okay, we proceed to the next question. 4.124. A frictionless piston cylinder device initially contains air at 100 kPa and 0.15 meter cube. At this state, a linear spring Fx is touching the piston but has no force on it. The air is now heated to a final state of 0.45 meter cube and 800 kPa. Determine the total work done by the air, and B, the work done against the strain. Also show the process on a PV diagram. So we have done this similar type of question in class. So for this kind of question, you have to use to calculate the area under the curve. So first is to do the PV diagram so that you can clearly see the which area you want to calculate. Okay, so it's PV diagram, PV. So your initial state first is, okay, 0.15 and 100 kPa. So this is kPa. This is meter cube. Okay, so this is your first state. Okay, second final state is 0.45 to 800 kPa. So it's like this. Okay, so you have to calculate the total work done by the air is actually the area under the curve here. So it's the trapezium area. So for A, so the formula for trapezium is 1/2 A plus B multiplied by C. So your A is 100 times plus 800, your B. C is the difference, 0.45 minus 0.15. So you get 0.3. Okay, so solve for this and you will get 135 kilojoule. Okay, so part B, the work done against the spring. So it is the triangle here. Okay, so 1/2, the difference 800 minus 100, 700 multiplied by the height. Okay, 0.3. So you will get 105 kilojoule. Okay, I'll stop here.